Hello students, welcome to the next YT session. I hope I'm live. Yes, let me check it quickly. Yes, I guess yes. Okay, fine. Welcome to the new session of class 9th physics. And well, in today's session we are going to discuss two very important topics for ICSE class 9th physics syllabus, that are neutral points and electromagnets. And yes, let me first introduce myself. My name is Kalyan Krishna Awasthi. I am be your physics educator for the session. And as far as my credentials are concerned, I am masters in electronics, and right now I'm pursuing my PhD in the same very field with my area of specialization as wireless sensor networks, right? So I'm working on wireless sensor networks as of now. Well, in today's session, what we are going to study? Well, we are going to study neutral points and electromagnets. But before we start, let me quickly brief you and let me ask you to join the Telegram channel, right? The link is present in the description box. If you haven't joined it yet, this is the right time. And why am I saying this? Join the Telegram group to be updated with all the recent videos, all the contents that will be shared in a while, right? Well, if you are here, I hope you have already subscribed. In case you haven't subscribed the channel yet, go for it. We are targeting for a 1000 subscriber count. And yes, don't forget to click the bell icon, right? Just like it, subscribe it, and click the bell icon. As soon as you click the bell icon, you'll be updated with all the upcoming videos, all the premieres, everything will be updated, right? So well, I hope you'll be doing so, and I welcome you all in this particular session. And before I start the session, let me quickly tell you about this very exciting examination, exciting scholarship exam, that is Unacademy Prodigy. It's back again, and well, you get a chance to win a lot of prizes here, right? You get a chance to win a lot of prizes. And the best part is you can enroll for this absolutely free. I mean, you don't have to shell even a single buck, and you can participate in this particular exam. The exam will be held on 4 dates. This is the very first date, and all the details of the same are there in the Telegram group as well. You can join that particular group. And why is it important? Because you get to win prizes worth 100 of crores, and the best part is they are providing you scholarships as well. I mean, you can score well and get an scholarship. A scholarship includes few plus subscription perks as well. Apart from that, you can win exciting prizes as well. You can see the prizes are being displayed. You can win a tab, you can win a laptop. So that is the best part for the exam. I mean, you'll get to see your preparation, and at the same time, if you score well, you will get to learn a lot of things. You'll be getting a lot of prizes as well, right? So now let's start without wasting any time. This is the topic for today's session, right? We'll be starting with the neutral points and electromagnets. So before starting the topic, like I always do, it's very important to know the backstory, right? I mean, you cannot start instantly from a particular topic and just get connected. You have to know the backstory. If we are talking, hi everyone in the session. Hi beta, hi. Hi. So if we are talking about the neutral points, we should rather know the backstory. And what is the backstory of the neutral points? See, for understanding neutral points, we have to understand that how these points are created. If we get to know the core concept of how neutral points are formed, then only we can understand it and remember it for a longer time. See, first thing first, we are talking about magnetism. That means these neutral points have something to do with the magnetism. And what exactly they do is, neutral points, in neutral points, we talk about the magnetic field, rather the net magnetic field. Okay. Whenever we are talking about the neutral points, we are actually talking about the net magnetic field at a particular point. Okay. So what is the backstory? If you want to understand what neutral points are, you should rather start with magnetic field. Okay, and that too a very prominent property of magnetic field. Magnetic field is a vector quantity. Now this is the catch, right? Magnetic fields are vector quantities. Now can anyone tell me in the chat box what is a vector quantity? Come on, I know all of you know this. You're grown-ups, you're in class 9th, you have studied this in term 1 as well. Can anyone quickly tell me in the chat box what is a vector quantity? Yes? Come on. Come on. I know you know this. Yes. What is a vector quantity? A quantity that has magnitude as well as direction is called a vector quantity. Okay. A quantity. Yes. That depends on. Yes is right. You're saying a quantity that depends on both magnitude and direction. Okay, fine. So you have a magnitude plus you have a direction, right? That is why the quantity is a vector quantity. Now this direction is important for neutral points. Okay, this is where, yes, this is where we get to get the proper connection. Now see, what does the word neutral means in electricity? I mean, if I'm saying that something is neutral, so what does it mean in terms of charges, in terms of polarities? What does a neutral world mean? Yes, any of you? If I'm saying a neutral, so what does this mean? Neutral means no polarity. Okay, no polarity. And why is polarity important? Polarity is important for magnetism. Okay, and magnetism is experienced only if there is magnetic field. So if I'm saying that there is a point which I'm calling a neutral point, can you tell me about the magnetic field at that point? Okay, Yash is saying equal number of Yash, you were saying Mandal is correct, no charge. See, both of you are correct. You are replying in terms of charges. I am telling you in terms of magnetism, right? See, no polarity means no poles, right? Neutral means no polarity. No polarity means no poles. No poles means no magnetism. No magnetism means no magnetic field, right? Now you get on to the definition. If I'm asking what is a neutral point, you should rather say, so neutral points are the points. Yes, sorry. Yes, I forgot. Yes, Krish. Your name is, you, your name, you have kept a very, distinctive name. So I was confused. Fine. So Krish, what I was saying is a neutral points are those points where you cannot have any magnetism. And since you cannot have any magnetism, so the net magnetic field has to be zero, right? So if I'm asking you, what is a neutral point? You should rather tell me, sir, neutral points are the points where the net magnetic field is zero, right? Now, here comes the answer. Magnetic field is a vector quantity, okay? If magnetic field is zero at a point, this means that the magnitudes are equal but the directions are opposite. That is why the net value is zero, right? Right, Yash? Right, Krish? Yes? Who else is present in the session? Come on, quickly. Yash, why are you retracting your messages? I mean, why are you deleting the messages? Any issues? Krish, can you tell me? Krish or Yash, or maybe anyone in the session? Okay, fine. Let's start the topic. So I guess you got a basic idea of what neutral points are. Neutral points are the points where the two magnetic fields are equal in magnitude but opposite in direction, right? Yes? Okay, you got this logic clear? Neutral points are the points where the two magnetic fields are equal in magnitude but opposite in direction. Okay, that is why both the fields cancel out each other and we get actually a zero field at that particular point. Okay, The next point says that the net magnetic field at neutral points is 0. Obviously, it has to 0. It has to be 0, right? And how do we get to know that the magnetic field is 0? The presence of a magnetic field is basically checked through a compass needle. We know this. Yes? All of you know this? How do we check the presence of a magnetic field? Yes, quickly. Hi, Shiv. We check the presence of a magnetic field at any particular point by placing a magnetic needle or a compass needle at that particular point. Fine? Yes? Okay, fine. Now see, I've taken this particular slide. Yes, Yash is saying it's clear. I've taken this particular slide, but let me explain you how this slide came and what exactly we are trying to convey in this particular slide. See, here I have depicted a non-uniform magnetic field curve. Now here, see, if I'm saying this is a bar magnet, for example, yes, in fact, it is a bar magnet. Now, a bar magnet should have its magnetic field. Yes, it will have. A bar magnet will have its magnetic field. I'm saying, see these points. These points. These are the points where no net magnetic field is there. So these are my neutral points, okay? But how did I get these neutral points? A bar magnet will have its own magnetic field. Yes. And how will I get to know its magnetic field? I have to plot its magnetic field lines. And we know the basics of a magnetic field lines. They originate from the North Pole and move towards the South Pole, right? They originate from the North Pole and move towards the South Pole outside the magnet, and within the magnet they move from south to north. We're not dwelling into that territory today. So see, there is a bar magnet, it is placed somewhere, but just see that I'm saying that these are the neutral points. Now, for these neutral points to exist, the net magnetic field has to be 0. But for the net magnetic field, we need one more magnetic field, right? That is only when we can say that, okay, we had two magnetic fields. One of the magnetic field was because of this bar magnet. And where does this second magnetic field come from? I mean, if we are talking about the neutral points, what is the reference for it? I mean, how actually can we get neutral points? Yash is saying, what are neutral points? Yash, neutral points are the points where the net magnetic field is 0. Okay, just see the preceding slide. Yes, neutral points are the points at which the two magnetic fields are equal and opposite, and the net magnetic field is 0. See, magnetic field is a vector quantity. Magnetic field is a vector quantity, and if we have two magnetic fields, say M1 and M2, which are equal in magnitude but opposite in direction, I mean to say this is the direction of M1 and this is the direction of M2, so we can clearly see that both the fields are equal and opposite in direction. So if we get, this is the basic rule of vectors. I mean, we have studied vectors in term 1, scalars and vectors. When two equal and opposite vectors are acting at a point, the net resultant is 0. Okay, yes, you know this. If two equal and opposite vectors are acting at a point, the net resultant is 0. Come on, tell me in the chat box. All of you know this, or should I mathematically show you how does this happen? Okay, fine. I guess you know how this happens. Okay, fine. See, so what I was talking about, I was saying that, okay, Yash wants a reason. See, this is how we find the resultant of two vectors. F1 is square plus F2 is square plus 2 F1 F2 cos theta. Okay, this is the formula for finding the resultant of two vectors at any point. Now see, I'm saying two vectors are equal. That means F1 and F2 are equal and they are opposite. Okay, they are opposite. Now tell me, if this is F1 and this is F2, See, theta is the angle between the vectors. What is the angle between F1 and F2? Okay, Prabhat wants a one short lecture. Prabhat, which topic? One short lecture on which topic, beta? You can go for the special classes. They are one short classes. Okay, tell me what is the angle between F1 and F2. Can anyone in the session tell me? These are two vectors, and what is actually the angle between F1 and F2? See, this is the angle, 180 degree. Okay, the angle between the two vectors is 180 degree. And I mean, I don't know you know this. I mean, you must not be knowing cos 180 degree is -1. Okay, cos 180 degree is -1. That is what I was saying. Yes, that is what I was saying. You can take it. Cos 180 is -1, so you will be getting f1 square plus f2 square minus 2 f1 f2. I'm just showing you. You said na you want the solution, so this is how it comes. This is f1 minus f2. Now if f1 and f2 are equal, this r will be 0. This is how the net magnetic field becomes 0. Okay, in fact, for any vector, this is how the net value becomes 0. Got it? Yes, Krish, Prabhat. Yes, fine. See, so what I was saying is that why did the net field become 0? For that, we should have two fields. We understand that one field is because of this magnet. One field is because of this magnet. But what about the second field? Where does this second field come from? Can anyone tell me? Where does this second field come from? The second field is the Earth's magnetic field. It is Earth's magnetic field. So whenever we are talking about the neutral points, we are always talking, yes, you replied correctly. Whenever we are talking about the neutral point, no, it's not different, beta. We were talking about the neutral points, right? We were supposed to talk about the neutral point. See, in order to relate the concept, I'm telling you the backstory. I always do this. The topics are, I've taken the topics from the ICSE syllabus only, beta. They're not different. Just see, you'll find this diagram in your book. Okay? You'll find this diagram in your books. It's not different. It's just that, I'm telling you how. And I mean, see, being a science student, you should always ask why. So I'm telling you that why. This is what I am telling you. See, what I was telling you is that the other field is the Earth's magnetic field, and Yesh was correct in this regard. Okay, so now neutral point is created when two fields are equal and opposite. So what is the important point here? The important point is here, whenever we place a bar magnet with its north pole facing the Earth's north pole. Okay. Okay, thanks, Yash. Okay, fine. See, this is the north pole of the magnet. What I wanted to convey is, whenever you are taking a bar magnet and you are putting the north pole of the bar magnet towards the Earth's north direction. I mean, see, I have taken these directions here, east, west, north, south. If I place a bar magnet such that the north pole of the magnet, yes, Krish, I mean, I hope you like this, na? I mean, you want a teacher who goes deep in the topic, don't you? I mean, in class 9th itself, if you are given this much knowledge, this deep knowledge, you don't know, you will be prepared well for your JEs or maybe NEET exams, You will get to realize this afterwards. अभी तो you're thinking कि sir is giving deep knowledge, but when you'll appear for your JE or NEET na, then you'll remember my name. You'll recall me. There was a teacher who told me in class 9 that there has to be 2 fields, then only you'll get a network. It's a slow process, beta. It's a slow process. And just see, I always tell my students, you have to trust 3 persons in your life, either completely or you don't trust them at all. First is your lawyer. I mean, either trust your lawyer or don't trust him. I mean, it's not that partial trusting is not done with lawyers. The second is with doctors. I mean, you either trust your doctor completely or you don't trust him actually. If you trust him, you have to take the medicine what he has prescribed. And the third one is with the teacher. Okay, if you are considering a teacher as your mentor, if you are following a teacher, you have to completely trust him. That depends on you. I mean, which teacher you are following is particularly selected by you only. No one in the world can help you in this regard. It's up to your level of understanding whom you are idealizing, whom you are following. But in case you are following a teacher, you should follow him blindly. Right? Yes? So slowly, and I am a slow poison. Slowly and steadily you will get to realize कि सर ने गजब की चीज बताई है. Right? Fine. Chalo, let's continue. So what I was saying is, if the north pole of the magnet is pointing towards the north of the earth, right? In this particular case, the neutral points will be created at this point. Okay, I mean, this is along the axis. See, for that matter, along the horizontal line, right? You're getting my point. If the north pole of the magnet is pointing towards the north of the earth, you'll get neutral points along the horizontal line. Every time you'll be getting the neutral points here only. This is fixed. In class 9th and 10th, I am telling you, in class 12th, I'll prove it. Okay, in class 12th, in magnetism, we'll prove it mathematically that neutral points are lying along this equatorial line. There is a proof. Yes? Okay. But what I wanted to convey is, in case there are neutral points, that means there has to be 2 magnetic fields. I mean, you cannot have a neutral point with a single magnetic field. So one magnetic field is because of this particular magnet, the bar magnet that you are considering. And the second field is the Earth's magnetic field. Okay. Now see, Earth's magnetic field is very important. It is playing a vital role. Okay, you want the details for the next special class. Today is 18th, right? The next special class is tomorrow. Tomorrow is the next special class. Permanent magnets. And one more thing I want to tell you in this particular session only. In tomorrow's class, we'll be doing 5 to 6 very good questions. I mean, it appears as if permanent magnet is a very small topic. How will you take a 1 hour lecture on this? You'll get to realize in tomorrow's class, 19th, yes, how we can, make permanent magnet a very technical and a very interesting topic. Okay, so don't forget. I'll be recapping with magnetic field. Okay, magnetic field. Yes, in one of the sessions I'll do it. In one of the special sessions, actually, we'll be doing it. Don't worry. Yes, I can recap it on 21st of Friday. So see, don't miss the sessions. In the special classes, you have the option to ask the questions. There is a doubt tab for you. Just ask the question in the doubt tab. I'll reply. If you have a problem in magnetic field, ask it. I'll reply. Tomorrow again. Today is 18th. Na? Today is 18th. On 20th, we'll be having the next YT class. Okay, yes. The next YT class is on 20th. Yes, I'll be posting it. Today is the first plus class. Krish, today is the first plus class. Let the class be over. I'll be posting the questions that I have done in the Telegram group. Okay. Let the class be over. 20th, the topic will be permanent magnet, and I'll explain you the working of electric bell. Okay, I'll explain you the working of electric bell, which basically is the application of electromagnets. Okay, which basically is the application of electromagnets. Let me quickly tell you. See, this is what I was telling you all this while. The new batch, the Mavericks batch, it has already started from 17th of Jan. Okay, so these are the faculty members who will be teaching in the Mavericks batch. The mode of delivery is English. Krish, you should go for the plus subscription. Krish, you are there on the Telegram channel. You can join. I'll be updating the schedule there. You can join there. Okay, no, not a problem. You should rather take a subscription now. It's high time. It seems you are quite inquisitive. The questions that you throw are very logical. You deserve to be at the plus platform. I mean, the level of questions that you throw are very good. So you should be there. Okay. This is the name of the batch, the Mavericks batch. In case you are interested in English, if you want the mode of delivery to be English, you can join the Mavericks batch. And for Hindi, you can go for this Udan batch, right? These are the details of the faculty members who will be taking up the classes. Okay. Yes, I'll be continuing with the topic. Let me finish it off with this. Yes. I hope you're finding the session interesting. So these are the details of the batches which I am expecting all of you to join ASAP. I mean, whatever you are seeing here is just 30 to 40%. This is just the trailer. Krish, first of all, offline nowadays is not that safe. I mean, look at the pandemic situation. It's better to stay indoors, and Unacademy is there for you, to ensure that your studies don't hamper. You can rather go for this Unacademy subscription. Okay. And well, you can go for a 12 or maybe 48 month subscription. You are in class 9th, then it will be for class 10th only. You won't be getting these offers every time. Just look at the offer. If you are subscribing for class 9th, you get the class 10 to 12 free. I mean, every time you won't be given this opportunity. It's okay, you have taken offline classes, continue with the offline classes. In online classes, you can attend the classes, not an issue. I mean, no offline classes are at 9 p.m. in the night, or are they? I mean, 9 p.m. koi coaching nahi khulti, so you can go for it. I mean, we start at 9 for physics. Okay, so you can rather go for it. Yes. Chalo, let me tell you this. Now just see one thing. The another scene. Now here, what is the difference between the two diagrams? This was the first one, this was the second one. Can you tell me the difference? Yes? Any one of you, can you tell me the difference? Yes, Krish. See the position of, see the position of the north and the south pole in the two diagrams. Okay. See the positions of the north and the south poles. Can you find something different? I mean, what is the difference? Anyone? See, in this particular diagram, the north pole of the magnet was towards the north pole of the earth. Okay. Yes. But here, the south pole is towards the north pole of earth. And what else can you find? What else can you see in the two figures? Okay, I guess we have a question. Someone has asked a question. Yes. Hi, Renu. You have asked the question, bar magnets lose magnet when heated. Why? You mean to ask why do bar magnets lose their magnetism, right? I mean not bar magnets. The question can be generalized for any magnet. Yes, this is what you want to ask. Come on, your name is Vasu Kaushal. Yes, Vasu Kaushal, this is what you want to ask. Yes, come on, quickly. See, you are in class 9th, I guess, right? Vasu Kaushal, you are in class 9th. I mean, the question that you have asked is related to the electronic configuration. See, let me tell you. Since you have asked, I'll be replying it. There are three types of magnetic materials: paramagnetic, diamagnetic, and ferromagnetic. Okay, these are three type of magnetic materials. In fact, based on their electronic configurations, based on the internal alignments, we have classified materials into three parts: para, ferro, dia. Yeah, para, dia, ferro. What happens in magnets? They form small domains. I mean, this is beyond your syllabus, but it's okay. You have found, you have asked this question. So what happens? Domains are small regions where these charges align themselves, or for that matter, we call them magnetic poles or magnetic dipoles. This is the name for them. I mean, this is way ahead of what standard you are in. Magnetic dipoles. Within the materials, there are small magnetic dipoles, and these magnetic dipoles, align themselves in a particular direction when a particular magnet is placed in either an external electric field or an external magnetic field. So what happens when you start giving them additional energy? What happens to these dipoles is, normally, see, for all the three materials, the arrangement of the magnetic dipoles is different. I mean, they are differently aligned for para, dia, and ferro. Since I guess since you have ask this question, you must be getting ferro. Ferro is for iron. I mean, the magnetism power will be just it will take 5 minutes. Yes, just it will take 5 minutes. So what happens when you heat a magnet? I mean, this question is for class 12th. I don't know why Vasu Kaushal has asked this, but it's okay. So what happens when you heat a magnet? What happens? These magnetic dipoles, they misalign. Okay, and the magnetic property is because of the alignment of these magnetic dipoles within the substance. So what happens? You heat the magnetic material, and these magnetic dipoles are misaligned, and because of this misalignment, they lose their magnetic properties. Now, how much magnetic property will be lost? It depends on the type of material. I mean, paramagnetic material will have a different effect of heat, dia will have a different effect of heat, and ferro will have a different effect of heat. And all these three effects, although will be closely governed by a single phenomena, but they'll replicate in a different way, right? Okay, so yes, it is very interesting. It is very interesting. I guess Vasu Kaushal is not in the class as well. You are there, Vasu Kaushal, right? I guess I'm spelling the name correctly. I'm pronouncing it correctly. Vasu Kaushal is there in this session. I mean, I cannot. Yes, I need a reply. I mean, is it okay? You got your answer? See, one thing I can assure you. In my sessions, all the answers, all the questions will be resolved. Be it YT, be it special, be it plus. Plus, me to I am bound to answer you. But here also, I'll try and answer every question. You can ask anything related to the topic, not like this. Okay, Gamers is saying we got it. Fine, chalo. Let's get back to the topic. What I was saying is, now see, just see the position of the neutral points. Now the position of the neutral points has changed. Yes. So this is what you have to remember in class 9. Okay, just the simple thing. If the north pole of the magnet is pointing towards the north of the earth, the neutral points will be along this this horizontal line, which we normally call equatorial line. Okay. And if the south pole is facing, the position of the neutral points will change. Right? Is it clear to everyone now? Yes, Krish, Vasu, Kaushal, XYZ, whoever is present in the session. Yes? All of you? All of you, come on, I need a thumbs up quickly so that I can move ahead. Yes? Yes, you are continuously changing your DP, I can see. I mean, every time the name flashes with a new pic. Don't do this, bhai. Chalo, the next topic that we are going to discuss is electromagnets. Okay. Electromagnets. So, we have had a very basic idea about this in the previous sessions as well. So, what is an electromagnet? I mean, I didn't get an answer from Vasu Kaushal whether the doubt was resolved or not. I'm still waiting. I mean, I don't know whether he or she has left or not. Okay, fine. See, so what are electromagnets? Electromagnets are artificial magnets. Now, Krish will tell me, why do we need artificial magnets? Come on. Come on, come on, come on. Who will tell me? For industrial uses. No problem, Viraj. I'm trying to improve. You can help me to improve. Right? There is always a scope of improvement for everyone. Yes? There is a scope of improvement for everyone. Fine. So, artificial magnets are the magnets which we design and they have enhanced power. I mean, the magnetic power is more. Okay, and why do we need electromagnets? We need electromagnets because natural magnets have weak magnetizing power and they are of irregular shape. They cannot be commercially used. We cannot use a natural magnet at a place where we require strong magnetic field. Why? Because they show weak magnetism. Right? So what should I do? Yes, Krish is right because natural magnets are weak. It's WEAK beta. It's not WEEK. Yes, Krish. So what we do? We go with electromagnets that are artificial magnets. Now, Viraj, what was your answer? I didn't get your question, beta. You didn't send a question. What was your question? What was your question, Viraj? I'll be more than happy to give you the answer. Where did you send? I mean, I didn't receive the question. Where did you send? Where did you send the question? Arey beta, where did you send the question? I didn't receive the question. You can ask now, na? We are live. You can ask the question. Any question related to the topic. Ask it now. We have Yash with us. We have Krish with us. Yes, Yash. Now your message is fine. A number of students are there. You can ask your question right now. I mean, everyone can see it. It cannot be, deleted. It cannot be edited. We are live. Ask your question. Just type your question and let me continue. Okay, fine. No issues on that. All your questions will be answered. Right? Fine. So, a very important point for electromagnets is that their magnetism is not temporary. I mean, they do not possess permanent magnetism, right? As long as the current Actually, what happens is we prepare electromagnets through, by winding coils on a sheet and then passing current. And as long as the current, you must have heard about solenoid. Yes, solenoid, right? You have heard about the solenoid. That is an artificial magnet, right? So what actually happens? How can we increase the power of the magnetism, or the intensity of the magnetic field? By increasing the value of the current, right? So what happens if, for instance, we stop the current? So will it possess magnetism? No, it will no longer be a magnet. As long as the current is flowing, the arrangement will behave as a magnet. So that is why we call it a temporary magnet. Okay, a temporary strong magnet. Fine. Yes, it is very important point. This magnetism is temporary. Okay. Now, there are two very popular electromagnets that we normally come across. The very first is I shape or a bar electromagnet, right? Krish, I guess this is no problem, no problem, no issues. Krish, have you seen a bar magnet or a bar electromagnet? See, what actually happens? Yes, you're getting my point. How do we form a bar magnet or a I-shaped electromagnet? This is how we do. What we do is we take a sheet, right? Or for that matter, we take a sheet, and what we do is we wound wires over the sheet, right? You can see these wires, right? These are the wires that are wound on the sheet. And what happens? We connect a circuit. This is the circuit which supplies the current. We connect this particular circuit. Okay, you have seen a magnet which is in your speaker. Okay, fine. At least you have seen. That is the best part. At least you have seen. So what happens? As soon as we plug this key, the circuit is complete, and the current starts flowing in the circuit. This is how the current flows, right? Now what happens when this current starts flowing in the circuit? We normally use a soft iron core as a sheet. Soft iron core. Okay, we use a soft iron core. And what happens when we pass current through this particular arrangement? A magnetism is generated. Actually what happens, the current effect generates the magnetic property. And how do we get to know that magnetic properties are induced? For that, this is the trick. I mean, for magnetism to be induced, we should have a north pole and a south pole. Only then I will say that the magnetic property has been induced, and now it has become an electromagnet. Otherwise we can't call it as an electromagnet. Yes or no? Yes, we cannot call it an electromagnet until and unless polarities are developed. See, polarity is the very basic thing. You cannot have a magnet without polarity. I guess somebody asked this in the previous session as well, right? Somebody asked me in this previous session. I don't exactly remember the person who asked. The question was, sir, what is polarity? Okay. Yes, I was saying that what we do is we wind wires on the soft iron core or cardboard, and what we do is we pass current. When the current is passed in this circuit, magnetic properties are observed. And how do we get to know that which kind of polarities are formed? So for that, this is the trick. Just see, this S looks like clockwise current, right? It looks like clockwise current. Does it? And it looks like anti-clockwise current. So at point where the direction of the current is clockwise, we say that a south pole is created. And where the direction of the current is anti-clockwise, we say that a north pole is created. So this way, two polarities are formed, and we say that the magnetism has induced. Now the question is, can I increase the strength of magnetism? Can anyone tell me in the session, can I increase the strength of this magnetism or this magnetic field? Do I have a provision of increasing the strength of the magnetic field produced? Any one of you in the session who wants to reply? Okay, Krish is saying yes, you can increase. How can you increase, Krish? Yeah, change your name. I always get confused. Why have you used this name? I mean, it's very weird. Why have you used this name? Yes, by current. Yes, you can increase the value of the current, and this way the magnetism will increase. Or any other method, Krish? Any other method? Okay. That is why every time you come, I get confused. Okay, no problem. Now I will remember. This is your mom's ID and you are Krish. Fine. Okay. Any other option? Any other method for increasing the magnetism? Any of you? Yes, you want to reply? I mean, how can I increase the magnetism further? We can increase the magnetism further by increasing the number of turns. Okay, by increasing the number of turns. This is the other type of electromagnet that I was talking about. But before that, let us quickly go through this. Yes, by coiling the wire. See, this is my code, Kalyan Live. You can use this code for availing 10% instant discount. KALYANLIVE. This is my code. Okay, you can use this code, and the best features are, the very first thing is that you can learn at the comfort of your home. The session is not over. Yes, 2 slides are still left. See the horseshoe, and but let me quickly go through this. Yash and Krish. See, now your name is live on YT as well. I mean, Yash and Krish. Fine. See, unlimited access. The best part is once you get the plus subscription, and okay, Yash knows that it is till 8:45. You can access the content unlimited number of times. That is the best part, and you get to learn from the top educators. I hope whatever teachers you are learning through, they all are good. So this is the best part. And for me, what I personally like is this part. I mean, every time in every session I tell my students, this is the best part. Yes, Krish, I always post on the Instagram. The next, for class 9th, the next special class is tomorrow. Okay, I'll be explaining permanent magnets, right? And I'm again repeating, we'll be doing lots of questions in tomorrow's class. Okay, tomorrow we'll be doing lots of questions, lots of polls, lots of MCQs. I mean, whatever we have covered in the previous sessions, all the questions will be done tomorrow and day after. So don't miss any of these special classes. Okay, and yes, use this code to get the plus subscription. It's very good. So I was saying, this is the best part about Unacademy. Every 4th class is a doubt clearing class, and I love to address doubts. I mean, I love to address these doubts. No, tomorrow it won't be over. Yeah, the timings for the special class are fixed, 7:45 to 8:45. Every time you will have the class at the same time. Okay, the special class is fixed. Only The dates might vary, but the time never varies. Okay, Krish and yes. So what I was saying, and you get this PDF part and all. I have been telling you, this is how you can go for it. Just look at the pricing. As soon as we move ahead with the dates, with the tenure, the pricing becomes excellent. And for 48 months subscription, they are offering 67% discount. I mean 67% discount, which brings the cost per unit per month as 750. With minus 10%, I mean it's peanuts. So this is the best that you can get from any of these portals, right? And these are the features of the plus class. Why am I asking you, whoever is watching this video, if you have found the content worthy enough, just enroll for the special class. Why am I asking you to enroll for the special class? Because there we get to conduct a number of polls. Polls help us a lot. Why? Because we get to know our understanding, our level of standing. After every poll there is the leaderboard count, where we get to know who was the leader for the entire session. Then you have this doubt session as well. I mean, a window pops up and you get to write anything. I can see it. Even there is an option for attach an image. You can even attach an image if you want. Okay, and all your doubts gets resolved. And how can you watch my special class? If you haven't downloaded the Unacademy app yet, just go for it, install it, get started, enter your mobile number here. Okay, create your account by writing your name, select your goal. Obviously it would be from class 6 to 12. You'll get a drop down where you can type your class. It must be ICSE 9th or 10th, whichever class you are in. Select your language. Obviously if you're an ICSE student, you'll prefer for English, right? This is how you can go for it. Okay, now before recap, let me first finish the topic. So this is the second electromagnet that I was talking about. Now can you tell me anything different that you can visualize in this particular diagram? I'll directly tell you the best part. See, the basic logic is same. There is a core. The core is in U shape. There is some winding. Winding is wire is wound on it, and obviously there is a circuit which is providing current. U is the shape. That is why I'm calling it U-shaped magnet. It looks like an horseshoe. That is why we call it horseshoe electromagnet as well. The question is, what is okay? Krish is saying anti-clockwise. What anti-clockwise? I didn't get you, beta. What anti-clockwise? What exactly do you want to convey? Yes. What do you say? I mean, what is there anything unique that you can see? See, if you clearly observe the the way in which the wire is wound on the soft iron core, you can see that in this particular part the wire is wound in clockwise direction, right? In this particular part the wire is wound in the clockwise direction, and in this particular part the wire is wound in anti-clockwise. Just look at it. Yes, just look at it. Krish, P is clockwise. Just see carefully. P is clockwise. I mean, just see how it started. Okay. See, just you can take the hint from here. There is a south pole. So it has to be clockwise. Otherwise, you'll never get a south pole, right? And here, you're getting a north pole. So it has to be anti-clockwise. Then only you will get a north pole. So this is how you can quickly check. Okay. Means You can check whether it is a north pole or a south pole. This is the method to check it, right? All of you, is it okay? And one more thing, just see that the wire comes in front from here and it goes from the back side of the second, arm. Yes. Yes, you got this point. Now someone has floated a question, an irrelevant one. Why cotton textile industries was concentrated? See, you should get a, you have to observe it from here. You have to, or for that matter, if you're not able to relate with it, just see this. If it is a south pole, it has to be clockwise. I mean, this is the catch. I mean, I guess now somebody will ask me in one of these sessions, ki, sir, how does human brain work? I mean, only these kind of questions are left now. The, can anyone reply why cotton textile industries was concentrated near sea route area? I mean, it's very funny to have this question. Krish, Yash, can you reply this question? Yes, you got your answer. I mean, just look at the south and the north pole and you will get this answer for your question. Okay. Now, no, it's not. Without looking at the south or the north pole, you have to, check your point of vision. Then only you will be able to decide whether it is a south pole or a north pole. That doesn't matter. If you are winding the wire in a different way, you can either change the poles as well. That doesn't matter. Okay. The logic remains the same. The direction, I mean, it's a 3D figure. It's like this and the wire is wound, but I am showing you the picture on a two-dimensional diagram. So it is a bit difficult for you to visualize. So that is why I am saying just concentrate on the south and the north part. Okay. That will help you get the answer in a better way. No, not the waste, because the transportation becomes easy. This is also a valid reason. We make S like this. This is S. Okay. Now tell me what is the direction. And let me make N. Now tell me what is the direction. This is the direction. This is clockwise. This is the direction. This is anti-clockwise. Okay. Just remember this. After that, no doubt will ever, come into your mind. Right? So I was telling you, okay, Yash, this is the convention. This is the trick to remember the direction. You'll get to learn the mathematical part. Fine. Yeah, it is a valid reason. I hope you're convinced now. Fine. Chalo, quickly let's wind off the session. Uh, I've told you earlier also, if I wish to increase the magnetic field, what I need to do is I need to. Today we have a plus class. Yes. Any of you will be there in the class? Yes, Akash. We'll be starting with reflection. I mean, it's going to be a very good class today. Reflection, I'll tell you a very interesting story about reflection as well in the class. Okay. This is how we can increase. I've already told you that in order to increase, you can either increase the current or you can increase the number of turns in the solenoid. Both ways, it's going to increase, right? Let's have a quick recap. What all we discussed in today's class. In today's class, we have discussed, the neutral points. For neutral points, you need two fields. One is the field of the bar magnet and the other one is the field of the earth, right? Then we have discussed electromagnets. Electromagnets are artificial magnets. Why did we need it? We needed them because there were problems with natural magnets. Okay, and what were the problems? The problem was that which kind of schedule? Yes, I can help. I mean, how can I help you on YT? It's not okay. So maybe we'll discuss in the plus class. Okay. So I guess this is all for today's session. I hope you found the session interesting. Yes, all of you. Krish, yes, that guy Vijay. Yes, you found the session interesting, all of you. Nahi, I mean, what do you want me to know? Which time? I mean, I'm not getting your question. What you want me to tell you? I mean, depends on the availability, depends on your, studying hours, what you have decided. How can you use the time productively? Very good. Be a smart worker. Be a smart worker. We'll discuss on this in the next class. Okay. Just remind me. I mean, the time is over now, so I cannot help you with it. Maybe in the next class, I'll tell you. Okay. We'll discuss this in the next class. How to use time productively. As of now, a very good night to all of you. I have a class in the next 15 minutes.